Picture this: machines that can think, learn, and adapt on their own. That's not science fiction, that's today's reality. The artificial intelligence revolution is in full swing, transforming the world as we know it. Take a look at the autonomous vehicles cruising our streets, the smart assistants managing our calendars, or the AI algorithms diagnosing diseases with astonishing accuracy. These aren't the dreams of tomorrow, but the innovations of today, all thanks to the power of AI. This technology, once the realm of science fiction, is now embedded in our daily lives, shaping the way we work, play, and interact. But the journey to this point wasn't a straight line. It was a winding path filled with breakthroughs and setbacks, triumphs and trials. So how did we get here? Let's rewind the tape. Our story begins in the mid-20th century, with the birth of artificial intelligence. A concept that was once merely a figment of science fiction began to take form in the brilliant minds of the era. It was Alan Turing, a British mathematician and logician, who first proposed the idea of machines that could think. His Turing test, devised in 1950, remains a benchmark for determining a machine's ability to exhibit human-like intelligence. Meanwhile, across the Atlantic, the first AI program was being developed. Alan Newell and Herbert A. Simon, two American researchers, created the logic theorist. This was a program designed to mimic the problem-solving skills of a human being. It marked the beginning of a journey towards creating intelligent machines that could not only replicate human tasks but also learn and adapt. The seeds had been planted, and AI was ready to grow. This was the dawn of a new era, the era of artificial intelligence. In the 1960s and 70s, Symbolic AI took the stage. It was a time of pioneering minds, pushing the boundaries of technology and understanding. The early pioneers, like Alan Newell and Herbert Simon, were trailblazers, developing the first symbolic AI systems. These systems were based on the concept of symbols, representing real-world objects and concepts, and they were capable of solving problems by manipulating these symbols. Their work was revolutionary, giving birth to expert systems. These systems were designed to mimic human decision-making, using logic and rules to solve complex problems. They were like early digital consultants, offering advice in various fields from medical diagnosis to geological exploration. The impact of these developments on the field was profound. It showed the world that machines could think in their own way. It paved the way for the AI systems we see today, capable of incredible feats of cognition and analysis. However, this era also saw the limitations of symbolic AI. These systems were brittle, struggling with uncertainty and ambiguity. They were also knowledge-intensive, requiring extensive programming and expert knowledge to function. But the AI journey wasn't always smooth sailing. In the 1980s and 90s, AI went through a period of disillusionment known as the AI winter. This metaphorical deep freeze was a time when lofty expectations met the harsh reality of technological limitations. The hype around AI had soared high, but the technology itself was unable to deliver on the grand promises it made. The AI winter was triggered by a cocktail of factors. There were significant funding cuts, especially in the United States, as agencies began to question the return on their substantial investments in AI research. This funding freeze stifled progress and led to a shift in research focus. AI research moved away from ambitious moonshot projects and towards more achievable short-term goals. The effects of the AI winter were far-reaching. It led to a slowdown in AI development and a loss of public and institutional confidence in the field. But it also prompted valuable introspection and recalibration. Researchers started to scrutinize the underlying assumptions of AI and rethink their approaches. But as they say, after every winter comes a spring. This period of AI winter was not the end of the road. Instead, it set the stage for the next wave of innovation, the machine learning renaissance. In the 2000s, machine learning and the internet age brought AI back to life. Imagine the scene. The world was rapidly digitalizing, every click, every search, every interaction becoming a data point. This explosion of data was a feast for budding AI systems, feeding their insatiable hunger for information. At the same time, machine learning was undergoing a renaissance. This wasn't your grandfather's AI bound by rigid rules and predefined models. Oh no, this was a new breed of AI, capable of learning from data, improving with each interaction, growing smarter over time. The world began to see the potential of AI in a new light. From automated customer service to personalized product recommendations, AI was no longer a sci-fi fantasy. It was real, it was here, and it was reshaping industries across the globe. This wasn't just a resurgence, it was a revolution, and it wasn't slowing down anytime soon. This set the stage for the next big leap in AI. In the 2010s, deep learning revolutionized AI. This new chapter in the story of artificial intelligence brought with it a wave of innovation that was nothing short of astounding. Deep learning, a subfield of machine learning, uses algorithms and neural networks inspired by the human brain to learn from large amounts of data. This revolution in AI led to breakthroughs in areas we interact with every day. Think about when you upload a picture to your social media account and it recognizes your friend's face, or when your home assistant responds accurately to your voice commands. These are just some examples of how deep learning has improved image and speech recognition, making our technological interactions more seamless and intuitive. But it doesn't stop there. Deep learning is also powering advancements in healthcare, finance, transportation, and even entertainment. It's helping doctors diagnose diseases earlier, enabling safer autonomous vehicles, and creating more immersive video games. It's clear that the deep learning revolution has significantly advanced the capabilities of AI, making it more integrated and indispensable in our lives than ever before. We've come a long way, but what does the future hold? As we look to the future, the possibilities of AI seem limitless. Imagine a world where AI advances to such an extent that it becomes an integral part of space exploration. We're not just talking about simple navigational systems. We're talking about AI that can make critical decisions, analyze extraterrestrial environments, and even conduct interstellar research on its own. It's a bold vision, but one that many experts believe is within our reach. Now, let's bring it back down to earth for a moment. Picture a classroom where AI plays a key role in the education of our children. Personalized learning experiences tailored to each student's individual needs, strengths, and weaknesses. AI that can adapt teaching methods in real time and provide instant feedback. An education system that no longer leaves any child behind, all thanks to the power of AI. But as we dream about these exciting possibilities, we also need to be mindful of the ethical considerations. As AI becomes more sophisticated, questions around privacy, accountability, and the potential for misuse become increasingly important. How do we ensure that AI is used for the betterment of society and not to its detriment? These are complex issues that require careful thought and discussion. There's no denying that AI has the potential to revolutionize our world in ways we can't even imagine yet. From space exploration to education, from healthcare to entertainment, the possibilities are truly limitless. But as we stride boldly into this new era, we also need to tread carefully, ensuring that we navigate the challenges and pitfalls that come with such powerful technology. The journey of AI is far from over. In fact, it's just getting started.